Hello, let us now find out what is the average value of AC over half a time period T by 2. Average value of AC over half a time period. We have already seen in another video how to find out average value of AC over one full time period. The value turned out to be 0, but now we have taken up the case where we need average value of AC over half a time period T by 2. Now T is related to frequency as 1 by F. You should be knowing it already. Okay. So the definition says average value of AC over half a time period is total charge flowing in time T by 2 divided by T by 2. That is total charge flowing in time T by 2 where T is time period. Or you can say it is the ratio of total charge flowing in time T by 2 to T by 2. So first we will evaluate or first we will find out what is this total charge flowing in time T by 2, then divide it by T by 2. Okay, for that we will use integration because the current is changing. If you want to find average value, we have to integrate. Let's say that after a time t, small t, after a time t, let's say the charge is Q and the current is I after a time t. Now consider a little time further, dt, very small time interval dt. dt is so small that you can assume this I to be constant. And the small charge that flows during this small time dt is given as dq equal to I dt. So how do we proceed? Consider a small time dt, time interval, you can take it that way, dt, such that current flowing during this time can be taken to be constant. That constant will be nothing but I. Okay? Right. I dt. Flowing in this time means what? In the time dt. But we want total charge flowing in time T by 2, for which we have to integrate. I naught sin omega t, that can be brought out. Right? But now we will use substitution method because omega t is there now here. We will take omega t as theta so that we will turn the time into angle by some method. Consider omega t as theta, then change the limits. Okay, because you have changed the variable here, here also we will have to change the limit according to this variable theta. So take theta as omega t, then differentiate d theta is omega dt. For given AC, omega is constant. So for dt you can substitute as d theta by omega. This dt here, no, you can substitute as d theta by omega according to this. Also theta is omega t, we know. So that just write this as theta. But omega is nothing but 2 pi by capital T into this small t here. But when you put this small t as t by 2, you will get theta as pi. See here, if I put theta here as 2 pi by t, for small t, if I put t by 2, this 2 will cancel. This t will cancel. So theta would become pi. When small t is t by 2. Right? I have shown here. Okay, next one. Okay, say simple. 0, this is the next step, no? So 0, 0. T by 2, pi. I naught. For this omega t, we put theta. For this dt, we have to substitute d theta by omega, that omega has been taken here. Now when you integrate this, you will get minus cos theta. This minus symbol is written here. Cos theta. Upper limit is pi, lower limit is 0. So you will have to evaluate the definite integral. Okay. So minus, from the previous step you got minus I naught by omega as it is. Cos, substitute the upper limit pi. Minus cos, substitute the lower limit 0 in place of theta. Cos pi minus 1, cos 0 is 1. So minus I naught by omega minus 1 minus of 1. Cos 0 is plus 1 here. So minus 2 into minus 1, you can assume minus 1 is there outside, so it will be 2 I naught by omega. This is only numerator. Denominator t by 2. So you should divide it by t by 2. Okay. You can take this t to the numerator, 4 I naught. This 2 you can take to the numerator, it will become 4 I naught. For this t you write 2 pi by omega for this t. So you are now getting 2 I naught by pi. So average value of AC over half a time period, 2 I naught by pi. 2 I naught by pi.